talk about, we're going to start talking about multiplying fractions, and we're going to start that by first talking about finding multiples of unit fractions. So we've already talked about what unit fractions are. We understand that they are fractions with a 1 as a numerator, or in other words, it represents one piece of a fraction. And so this is a word problem that we've actually seen before when we first talked about unit fractions, but I brought it back to kind of introduce our new topic of multiplying. So just to review, Emilio cut a sandwich into 8 equal pieces and ate one piece. He has 7/8 of the sandwich left. Emilio put each of the remaining pieces on a small plate. How many plates did he use, and what fraction of the sandwich was on each plate? So like I said before, we have already done this. Let me get a pen. And so here I have a model representing, this is the sandwich, the 7/8 that are remaining. And so before we decomposed fractions into unit fractions, so we already understand that 7/8 is equal to 1/8 plus 1/8 plus 1/8 plus 1/8 plus 1/8 plus 1/8 plus 1/8. Okay, but another way we can think about this is, isn't this the same as saying 1/8 7 times, right? 1, 2, 3, 4, 5, 6, 7. And we already know that multiplication is just repeated addition. So we can think of 7/8 as, adding 1/8 over and over again, or we can also think about it as just multiplying 1/8 times 7. So when we have when we have a fraction, we can break it down into a unit fraction and the number that we're multiplying that unit fraction by. So let's take a look at something else here. Remember how, before we've talked about multiples of whole numbers, and we find them by multiplying it by a counting number. So for example, 4 times 1 is 4, 4 times 2 is 8, 4 times 3 is 12, and so on. So we know that 4, 8, and 12 are multiples of 4. Well, we can find multiples of our unit fractions by doing the same thing. So here, if I have 1/4 times 1, it obviously will equal 1/4, and here's a model demonstrating that. So what if I had 1/4 times 2? So here I have 1/4, and I have 1/4 again. So if I have 1/4 in each of my two models, then 1/4 times 2 must equal, you guessed it, 2/4. Okay, in other words, it's the same as saying 1/4 plus 1/4, because remember, addition, repeated addition is the same as multiplication, okay? So what if I had 1/4 times 3? So I have 1/4 3 times, all right? So it's the same as saying 1/4 plus 1/4 plus 1/4. So 1/4 times 3 is 3/4. And there is another way you can think about multiplying by whole numbers. So any whole number can be rewritten as a fraction. I could actually say 1/4 times 3 over 1. Any whole number can be turned into a fraction by placing it over a 1, okay? And it makes sense because if you think about this as being a division symbol, 3 divided by 1, it would still be 3. And when we're multiplying, it is a little bit different from when we're adding or subtracting. Our denominators, they don't have to match, and we actually will just multiply the numbers as normal. So think about it as, a little multiplication problem down here and a multiplication problem up here. So if I just look at the top numbers, 1 times 3 is 3, and 4 times 1 is 4. So you will still get the same answer. Okay, this is just another way you can visualize the number. So let's do some practice. If I had 1/6 times 5, what would my answer be? I'll give you a little bit of think time. Okay, so if you wanted to turn this into a fraction, if you wanted to, put this over a 1, you could do that, and 6 times 1 is 6, and 1 times 5 is 5. So 1/6 5 times is equal to 5/6. And one more, if I had 1/6 7 times, or 1/6 plus 1/6 plus 1/6 plus 1/6 plus 1/6 plus 1/6 plus 1/6, what would my answer be? Okay, hopefully you got 7/6, because if I did have that 1/6 over and over again, I can't draw. Let's see, 2, 3, you're probably hearing my mouse clicking away, 4, 5, 6, and 7. Okay, so 1, 2, 3, 4, 5, 6, 7. That's 7 ones. So 7/6 would be the answer. Now you probably recognize that this is an improper fraction. Okay, so if I were to convert this, okay, 6 goes into 7 one time, so I would have 1 whole, and I would have 1 piece remaining. Okay, so 1 and 1/6 would be the correct, mixed number format of 7/6. All right, so we understand that we can take a unit fraction and we can multiply it to get a new fraction. Some different ways you might see this presented is they might have the whole number missing. So if we have the whole number missing, we have to figure out what the unit fraction is being multiplied by. And to figure that out, we'll have to look at the answer here. So again, you're probably noticing our denominators are not changing, but our numerator has become a 7. So what would I have to multiply 1/10 by, or how many times would I have to add 1/10 in order to get 7/10? If you said 7, you are correct. So 1/10 7 times would give me 7/10. So you're pretty much just going to fill in the whatever your new numerator is would be the whole number you multiplied by. Okay, and then sometimes you might even see it, I don't know why that's changing colors on me. Sometimes you may see it this way, and this is actually pretty simple. I have my unit fraction here of 1/8, and I am multiplying it by 5. And so my answer, they've given me my new numerator, so 1 times 5 is 5, but they haven't given me my denominator. And if you did convert this into, a fraction over 1, 8 times 1, you're still going to have 8. Okay, so again, your denominators are not going to change. And these are just some different ways that you may see problems presented. Also, just remember, we have our communicative property. The order does not matter. Okay, if I had 7 times 1/10, it'd be the same problem. If I had 5 times 1/8, okay, it would still be the exact same answer. All right, order doesn't matter when we're multiplying or adding. Okay, for your IXL practice today, please work on lessons S.5 and S.6. They're both dealing with multiplying unit fractions. Pretty simple. Don't overthink it. And I will talk to you guys later. Bye.